Okay, so let's look at domain and range. And we're going to start with some ordered pairs here. You should have this up on your sheet. So we've got this list of ordered pairs here: 7, 21, 8, 25, 9, 29, 10 and 32, 10, 33, 11, 35, and 12 and 39. And below that, we've got a table that's partially filled out and a graph. And so we're going to go in a little bit of review here. We've done this. We're going to go ahead and put in our ordered pairs, graph this, and then we're going to talk about how it relates to domain and range. So let's first start off with graphing this, and let's fill out this table here. And we've got some missing values that we need to go in and we need to fit. So they gave us the 721. We're good there. We have that down. But we're missing a value, an x value, for that 825. So I think that's going to be an 8 there. So we'll fill that in. So I got my 825. Next, I've got a 9, and this should be a 29. 9 and 29 there. Check, it got that one. After that, we've got a 1032. So let's throw in a 32 right there. Another 10. This got a 10 and a 33. So 10 is going to be our x value here. And then we've got 1135, so we're going to have an 11 in as an x value on that 35. And finally, last one, 12. 12 is going to have a y value of 39. And that's what we're used to doing. We get our x and y values. And then we can take these and we can graph them. Okay, so we'll try that real quick too. So I'm going to kind of blow up this graph here so we have a little more space to graph it. So let's graph these in. You can follow along in your paper. So we should have an ordered pair dot at 7 and 21. So I'm going to go 7x. Remember, x value is moving this way horizontally, y value moving vertically going up. So we'll start with the x at 7 and 21. So let's throw an ordered pair dot just right after 20. I got it just right after 20 right there at 21. So I got that one. Let's do one at 8 and 25. So I'm going to go to 8 and go right at the cross section on 25 and throw a dot in. Got it. I got 9 and 29 here, so I'm going to go with 9 and right before 30. It'll be a little tricky. I don't have a lot of space. Oop, I threw in 2 dots there. Let's just put in 1. That'll work. That'll work for now. That's at 9 and 29. We need 10 and 32, so 10 and a little after 32. Not quite halfway up, but just after 32. I'd say that'll work there for 10 and 32. 10 has got a second value also. It's 10 and 33, so that's actually going to be right after, I got my 32 there. That's going to be kind of like halfway in between. To see if I can fit it. Pretty good. Got it. So 10 and 32, 10 and 33 we just graphed. Then we've got 11 and 35, so I go to 11x and go up to 35, which is right at, kind of missed it there, but right at the cross section there for 11 and 35. And the last one was 12 and 39. 12 and 39. So I got 12, and let's take it up to just before 40. Nah, I don't like that. Let's go right there. That'll work. Okay. So more or less, not the neatest ever, but we've graphed these. Ordered pairs is the way we know them, okay? And it doesn't make a straight line. We're not necessarily looking at a linear equation here. We might be looking at a function. We'll talk about that. But what we started out is we are looking at domain and range, okay? So what we've just done is we were familiar with coordinates x and y, ordered pairs, and this actually fits into domain and range. So what are domain and range? So let's start with domain. So domain, got a definition here for you to get down. This is all of the possible inputs of a relation. So basically, these are all of the x values, any of the x values you see on a graph, on ordered pairs, on a table. That's your domain. Those are kind of your input values, inputs. So what is range? You probably guessed it. If the input values are your domain, then following that, the range is going to be all of the possible outputs of a relation. So these are going to be all of the y values. So again, domain, all of the x values, range, all of the y values. On a graph, remember this. So x values on a graph, remember those are your horizontal, going kind of sideways values, domain. Y values, or your range, are going to be, sorry about that, are going to be vertical messy, but vertical, going kind of north, south, up, and down, just like that. So on the table below, we can kind of fill in these domain and range real fast. So domain values, when we had these, are all the x values we'd have in these ordered pairs. So they'd be like these, 7, 8, 9, and so on. So we could fill them in, 7, 8, I got 9. I believe there's 2 10s in there, 10 and 10, 11 and 12. These are all domains. And then range would be those y values right over there, okay? The 21, the 25, the 29, and so on. So we can fill those out real quick. 21, 25, 29, 32. Now let's go with 33, 35, and 39, right? 35 and 39. Okay, so very similar to our ordered pairs x and y values. This is what domain and range is. This is kind of how they're defined. This is what we see. Okay, so let's try another example. So we got domain and range. Let's say if we can kind of pick these off a graph real quick. So a pretty basic graph that we have right over here, and we're going to use what's called a mapping diagram, and it's pretty similar to a table that we've seen before, but it's called a mapping diagram. I'll show you how it works. So we've got this graph. We've got 4 ordered pairs on here. So what we're going to do is set up a little bit of a table. We're going to call it a mapping diagram. So here's what we're going to set up. We're going to have basically an x side and then a y side. So have that down. Now the x, like we said, is going to represent the domain. We'll put that in parentheses, I think, if I can fit it in. I can. And the y side will be our range values, okay? So this is pretty straightforward, I think, and we'll go ahead and we'll fill this out. So we've got our x, we've got our y. Let's go and let's look at these graphed values right over here, and let's pick out, let's start with our domains. They're going to be our x values, okay? So they're going to be like the 7, the 8, the 9, the 10. So we can basically go in and we can list those, okay? So our domain values, 7, 8, 9, and 10 are all kind of our domains. And then ranges. Range are going to be kind of those y values that we have down at the end. So we've got like 14, 16, 18, 20. Let's throw those in. So 14, 16, 18, and 20. And what you'll see in a mapping diagram is you'll see these ovaled in. So it'll kind of go like this. You'll see an oval going around there. You'll see an oval going around there. And then you'll see some lines connecting the x and the y, or your domain and your range. So basically, like you'd see in your ordered pairs here, 7 and 14 kind of go together. They mapped up. 8 and 16, same thing. 9 and 18, and then 10 and 20. Okay, and so we just picked out the domain and the ranges. These happen to match up straight across, but that's not always the case. Okay, and I'll show you an example in just a second. But this is how we kind of picked off domain and range from the graph that we have with these ordered pairs. So here's that example real quick, and you just have this on your sheet of a mapping diagram here that comes from this graph right there that shows lines that don't necessarily go straight across. Okay, so if you check it out and see, just a real fast example here, like if I draw an arrow at this ordered pair, that's at 3 and 1. And you'll see 3, the arrow goes this way up to 1 because of the way they're kind of lined up. It's not going straight across. Another example would be like -2. You'll see right here, -2 actually has 2 ordered pairs from it. I'll switch to blue. But -2 has like a 1 here, and it also, there's a dot at -2, 3. So they don't always go perfectly across. I just want to make sure that I've kind of made that clear as we go across, okay? So then let's talk about functions. We've done a little bit with functions, and you got graph lines. So how can you determine if a graph line really is a function? If you've got a domain and range, you got a graph in there, is it a function? Is it not? Well, there's a test. There's something you can do real quick to make sure and to check. It's called a vertical line test. Vertical line test. So let's define it. Let's talk about it. What is a vertical line test? How do we run that? So a vertical line test says this, and make sure you get it down. It's a long definition, but I'll clarify. This is a vertical line test. It says a relation is a function if a vertical line does not pass through, I'll underline the not, does not pass through more than one point on the graph of the relation. Well, so what does that mean? Okay, so I've got this graph down here, this little graph. I've got four domain range. I've got these kind of plotted out here in a graph, these four ordered pair dots essentially. If we run a vertical line, remember vertical is going up and down, north and south. So if we run vertical lines through where we have these plotted, if they only touch one dot along here, they don't go through two, they only touch one, then yes, this is a function. Now, if I ran a line through here and it hit more than one dot, so let's say I had a dot also right here on this line, and that green line hit two, like I ran one line and hit two, then that would say no, it's not a function. So this is how a vertical line test works, okay? So if it only goes through one dot, only passes through one, then yes, it is a function, okay? And this kind of graph, by the way, with just dots that doesn't have lines, we call this, you can just jot this down, this is a discrete, D-I-S-C-R-E-T-E. This is a discrete graph. You'll notice there are no lines connecting these up, okay? And so a different graph that you'll see along with that, you'll see a lot here in algebra, is going to be what's called a continuous graph. And this is kind of where we end up here. And I'll write this down at the bottom, continuous, N-O-U-S, continuous graph. Now, you've got two continuous graphs to finish up with. If we run the vertical line test, are these both functions? Which ones are, which ones aren't? What do you guys think? Take a second, run the vertical line test, and let's see which one of these are functions. So if I run the vertical line test on this first one, this first graph here, that means I'm going up. It looks like I hit two spots on the line. Boom, one, boom, two. Again, hit one there, I keep going, I hit two. So remember, if you hit more than one, two, then no, this is not a function because I hit more than one spot, okay? So if we do the second continuous graph over here, and I say, hey, I'm going up, I think I only hit one spot right there. I think I only hit one spot right there. I don't hit another one. I hit one spot, I don't hit another one, and I hit one spot, then, okay, yeah, yes, this one is a function because we only hit one spot in there. All right, so that closes out our domain and range. Little bit on vertical line tests here at the end, but kind of showing how that connects to what you've known about ordered pairs with domain and range. Remember, domain, input values, x values, and range, output values, and y. Great job on the notes.